Good morning everyone, hope you are all good. Okay, we are dealing this lessons kinematics, motion of an objects or particles without taking the force into the account. Okay, so this week, today we are going to discuss about that degrees and the radians. Okay, degrees and radians. What is mean by radian? What is mean by radians? So radian is nothing but when an object, just think, consider about some objects are moving in the circular motions. Okay, so when an object moving in the circular motion, the length of the arc, how much of length is passing, the length of the arc, which will be equal to the radius of the arc, or you may say the length of the arc divided by the radius of the arc. Length of the arc divided by the radius of the arc, it is called the radian. Now, for example, the degree. What is meant by degree is nothing but your measurement, okay, which is determine the size of an angle, how much of angle is make and move. Okay, so degree is nothing but to measure the size of, to determine the size of an angle. Okay, so for angular displacement, what is meant by angular displacement? You may see lot of in circles there will be goes in the hell will, right? Hell something bite they will write on the inner globe, right? Say they have some angular centrifugal acceleration, centrifugal forces also will be there. We will discuss later. Okay, angular displacement. When an object moving in a circular motion, how much of what is meant by displacement? The total distance covered by an object. Okay, so when an object moving from one position to another position is displaced somewhere with respect to the time. Okay, what is meant by motion? It's nothing but the objects or particle moving or changing its position with respect to time. It is called motion. So when an object in the circular motion, this is your ds, or you may say that this is the displacement which is covered by that object. So this is your radius. The displacement related with the radius, it is called angular displacement. It is denoted by letter theta just by r. Displacement per radian or radius. Okay, then is equal to r theta. So angular displacements are always denoted by SI unit of the angular displacement is a radian. Okay. So what is mean by angular velocity? So angular velocity is nothing but rate of change of angular displacement. So it is denoted by letter omega. Angular velocity. Rate of change of angular displacement. So what is the SI unit of angular velocity? Radian per second. So radian per second inverse. Okay, omega SI unit of the omega angular velocity, radian per second. So what is a radian? Radian is nothing but the length of the arc which will be equal to the length of the radius of the circle. Okay, so angular displacement, how much of particle changing its axis of given axis. Okay, changing its position to the given axis. What is angular velocity? Angular velocity is nothing but rate of change of angular displacement. What is meant by angular acceleration? The angular acceleration is nothing but rate of change of angular velocity. It is denoted by letter alpha. Rate of change of angular velocity. So d omega by dt. The SI unit of angular acceleration, radian per second square inverse. Okay, radian per second square. Okay, now what is happen if the object are moving in the circular object? What's happened to the tangent acceleration? For example, the object is moving in a circular motion. Okay, this is your radius. The object take places to derivatives is making a move of displacement, changing displacement is making angular displacement d theta. We know the relation s equal to r theta, then ds will be equal to r d theta, right? So the object moving in a uniform circular motion with respect to time. So the time ds by dt will be equal to d theta by dt. The r is a constant because rate will never change. Okay. So rate of change of displacement. What is that? Rate of change of displacement is nothing but your velocity. Okay. So r rate of change of angular displacement is your angular velocity. So angular velocity. So the relation between linear velocity and then angular velocity. Linear velocity and that angular velocity v equal to r omega. V equal to r omega. Suppose what is mean by acceleration of the what is happening in the acceleration when it moves in the circular motion? Okay, what will happen to the acceleration of the particle when it moves with a uniform speed? Discuss centripetal acceleration. Before that, with the velocity, what is mean by acceleration is nothing but rate of change of velocity with respect to time. It is called angular acceleration or acceleration. Okay, so linear acceleration. So dv by dt will be equal to r d omega by dt. Okay, change in velocity, change in angular velocity. So we can write this as acceleration. Linear acceleration will be equal to r the angular acceleration alpha. The relation between linear acceleration and the angular acceleration. Linear acceleration and angular acceleration. Okay. The next one. What is mean by centripetal acceleration? Whenever the object moving with the velocity, the magnitude of the velocity will not change. Continuously will be the remain same. But okay, the velocity or the speed of an object will never change throughout the motion. So it is called centripetal acceleration. It happen only in the uniform motion. See here, the acceleration of the uniform motion. What is that? It is called centripetal acceleration because always the acceleration pointing to the center of the circle. Center of the circle. So it is called centripetal acceleration. It is called centripetal acceleration. Okay. Now, what will happen if the tangent will take place? Remember that a equal to minus v squared by r, because why is the acceleration velocity will be in the opposite directions. So v squared by r. We know the relation between v equal to r omega. So substituting there, r square omega square by r. 1r will be cancelled. So minus omega square r. So this is due to that uniform motion. What will happen if the speed is not constant? If the speed is a constant, then it moves in the centripetal acceleration. All the points marking towards the center of the circle. Okay, all the acceleration towards the circle. And what will happen if in the object moving in the non-uniform motion? Then acceleration will be equal to minus v r square by tan theta will be equal to acceleration by v square by r. That's it. Make an angle of tan theta, right? See, the particle, are we moving with the same speed during the night and day? Is it possible? See, this is our Earth, solar system, the sun. With respect to sun, the Earth moving in a elliptical orbit, right? Let us have the Vs. Okay, Vs. Because velocity of the Earth with respect to the sun. Also, Earth moving its own velocity, right? Earth also moving its own velocity. So what will happen? Which the velocity of the Earth will be taken as Vc. What will happen at the night time and the daytime? Night time and the daytime. Okay, at the night time, the velocity of the total velocity will be equal to Vs plus Vc during the night time. Okay, but during the daytime, d will be equal to Vc minus, Vs minus Vc. So what is happening? During the night, Earth moves faster during the night time than the daytime. So that's why we are feeling the daytime takes much more long time, but night time goes in the speed of light. Okay, because every time you are slept at the 12 o'clock and you can wake up at the 8 o'clock, it will be a fraction of seconds, right? Maybe you will feel like that. Say, okay, what is mean by the kinematic equations in the circular motions? Tell me what are the equations, kinematic equations? in a linear motion. First linear motion. Kinematic equations in a linear motions. V equal to u plus at. S equal to ut plus half at square. V square equal to u square plus 2as. S equal to v plus u t by 2. Right? These fours are called kinematic equations for linear motion. Kinematic equations for linear motion. What will happen to the circular motion? Simple. Where are you finding the v? The final velocity take as omega. Initial velocity omega naught. For acceleration, linear acceleration, there is an angular acceleration. For example, final velocity. So omega for circular motion. In the fifth lesson we can deal this one with the degree. Okay, v, which is an angular velocity omega. So initial velocity we can take as omega naught plus and linear acceleration, angular acceleration alpha times the time. Okay, displacement. This linear displacement, angular displacement. So theta will be equal to initial velocity omega naught t plus half angular acceleration t square. Here velocity square, so final velocity is nothing but your omega square will be equal to omega naught square plus 2 alpha theta, because angular velocity, angular acceleration, angular displacement. Angular displacement here, angular displacement when it moves in the circular motion. Omega plus omega naught t by 2. That's it. Okay, so the relation between linear motion and the circular motion for the kinematic equations, you have to write this one. It's a 2-mark question. That's it. Next one thing, on your third lesson. Okay, before the third lesson, we must know this one. Take the page number. Okay, in the live class, I will tell you all the important questions and then examples. You just note it down. Next lesson, on the third lesson, we will go for the third lesson. It is nothing but your laws of motions. Okay, do you know about Galileo Galilei? The famous experiment. What is that? The feather and iron bar. Okay, same, right? So the laws of motions. So here we are dealing with only laws of Newton's first law and third, second law and third laws. Okay, here also we will learn about the friction forces. See, laws of motions. What is mean by laws of motions? Okay, there are some laws. Okay, the kinematics deals with the object's motion and position without taking the force into the account. But here we are dealing with the lesson with the laws. The force also will be included. Force also will be included. Before that, you know what happened when Galileo did. So Galileo Galilei is the great physicist, whatever may be, okay. So the force, what will happen if the force of the ball or some other things when it goes in the smooth surface or when it goes in the inclined plane. He did one demonstrate and also he did one great job to find the force of the motion, because he did no force is required for the uniform motion, because the motion of the object will be goes infinitely when there is no forces or when there is no external forces is required. When there is no external forces is required. Okay. What he did, first he took one inclined plane, okay, one inclined plane with the same height, but there is a rough surface, okay, there is a rough surface. Inclined plane with a small same height with a rough surface. He rolls on the ball from the side S1 on the side S2. When it goes the ball with the rough surface, it reaches some height at the inclined plane, but it's not exactly on the same height. Okay. After he increasing that, he reduces that rough surface and increase the smoothness of the surface. Now it's released the ball from the S1. It reaches the same height. It reaches the same height. Now again, what he did, he reduced some angles or inclined angle. So he released some same bar from the height, same height. It reaches almost the maximum height. After, he increased the smoothness of the surface, and also there is no inclined plane on the side too. Now he released the bar, it goes in the infinity. It goes in the infinity. So what he did was to prove that there is no force required to maintain the motion or constant motion. No force required to maintain the constant motion. Okay, because Aristotle said there is one force is required to maintain the motion of an object, but he discovered that no need. Okay, he discovered that no need. Okay, so Aristotle coupled the motion with the force. Galileo decoupled the motion and force. Okay, so he proved that force is not required to maintain the motion. Force is not required to maintain the motion. Okay, Newton's laws. You know very well from the 6th or 7th standard itself. Newton's laws. What is meant by Newton's laws? Newton's laws is nothing but what? The first law, second law, third law. Every object continues to be raised or uniform motion unless it's compelled by the external force. Unless it's compelled by the external force. Okay. So lot of things you know. When you are sitting in the bus, when the driver suddenly applying the force, or when the bus is in constant motion, when the bus goes in the smooth surface, or when the train goes in the smooth surface, when the sudden applying of brake, what will happen? You cannot change its position, but you have to move forward, okay, or backward when they are pushing or pulling. Okay, so these are the examples of the motions. First law of motion is nothing but every object continues to be at the rest or in the uniform motion unless it's compelled by the external force or other forces. Okay, the inertia of rest. There is a page 1. Inertia. What is meant by inertia? The inability of an object changes position or changes motion with respect to the state of motion. Okay, the resistance to change the state. Okay, inability of object to move on its own or change the state of motion is called inertia. So what is meant by inertia at rest? Inertia at rest or inertia at rest. So when you are sitting inside the bus, okay, when you are sitting in the inside the bus also rest and you are also in the rest position. You are not changing your position, the bus also not changing the position. When the driver suddenly start the bus, what will happen? You are pushing backward, because this inertia of rest. You are the position, you are maintaining your motion with the rest. You are maintaining your position with the rest. Okay, suddenly the external force is acting. You cannot change it, continues your state of motion, or you cannot change its state of motion suddenly. So inertia at rest takes place. Okay. So what is happened? The inertia of motion. So what is the inertia of motion? When bus goes in the constant speed or constant velocity, when the bus goes in the smooth manner, okay, suddenly the driver applied the brake, what will happen? You goes forward and he will down the seat. Okay, so what happened there? You are maintaining that motion, but you cannot change its state of motion suddenly. Okay, when the external force is acting, that is called inertia of motion. So the inertia of direction, what will happen? The inertia of direction. So inertia of direction is nothing but what? You cannot change the direction, the object or the particle or the motion of the particle or motion of the direction, whatever it will be. Okay, the object cannot change its direction of its own. Okay, then it is called the inertia of direction. When you are rolling the stones on which is tied on your string, okay, suddenly you are stopping, what will happen? The stone will remove from that string and it goes and hit the target, right? So that's something like that. It is called the inability of an object to change its direction of the motion on its own is called inertia of direction. Okay, for example, when we say that the object is a rest of motion, is a constant velocity, the meaning of inertial frames. If an object is free from all the forces, okay, then it moves with a constant velocity or remains at rest when seen from the inertial frames. then there exists some special set of frames in which if an object experiences no force, if it is regressed, but how do you know whether the object is experiencing the force or not? All the objects in the earth experience the earth gravitational force. In an ideal case, if an object is in the deep space, very far away from another object, then the Newton's first law will be valid certainly. Such deep space can be treated as an inertial frame, but practically it is not possible. Practically it is not possible to reach such deep space and verify Newton's first law. Okay, the person and the vehicles are in the inertial frames. Okay, R2 is in the non-inertial frame. What is the frame of reference? You know that inertial frame and non-inertial frame. See, for all practical purposes, we can treat the Earth as an inertial frame because of an object on the table in the laboratory appears to be rest at always, but the object never picks up the acceleration in the direction of horizontal. So, since no force acting on it, since the horizontal direction. So, the laboratory taken place in the inertial frame for all the physics experiment and calculation. For making these conclusions, we analyze only the horizontal motion of an object as there is no horizontal force acts on it. We should not analyze the motion in the vertical direction as the two forces which is acting the gravitational forces downward direction and the normal force acting in the upward directions. That makes the net force because the gravitational forces will nullify this normal force. Our normal force nullified by the gravitational force. The Newton's first law deals with the motion of an object in the absence of any force and not for the motions under the zero net force. Okay. Suppose the train is moving with a constant velocity with respect to the inertial frame. Then the object is at rest on the inertial frame outside the train appears to be moved with a constant velocity with respect to the train viewed from the within the train. So the train can be treated as the inertial frame. All the inertial frames are moving with a constant velocity relative to each other. If the object appears to be rest in the one inertial frame, it may be appear to be moved with a constant velocity with respect to another inertial frame. For example, a car is moving with a uniform velocity. The car is moving with a uniform velocity when the person standing outside the car may be saved from that inertial frame. Okay, with respect to the person rest of the ground, both the frames, okay, with respect to the car and to the ground are the inertial frames. Okay, are the inertial frame. Suppose an object remains at the rest on the smooth table kept inside the train, and if the train suddenly accelerates, which we may say not sense, the object appears to be accelerated backward even without any force acting on it. Since the clear violation of Newton's first law as an object gets accelerated without being acted upon the force, it implies that the train is not an inertial frame when it is accelerated. Okay, so this is inertial frame and the car 2 is the non-inertial frame. These kinds of accelerated frames are called non-inertial frame. A rotating frame also called non-inertial frame since rotation requires acceleration. In this sense, Earth is not really in the inertial frame of reference or inertial frame since it has the self-rotation and orbital motion. But these rotational effects of Earth can be ignored from the motions involved in our day-to-day life. For example, when an object is thrown or in the time period of simple pendulum are measured in the physics laboratory, Earth itself rotation has very negligible effect on it. In this sense, Earth can be treated as inertial frame, but at the same time, to analyze the motion of the satellite and the wind patterns around the Earth, we cannot treat the Earth as an inertial frame since it is a self-rotation has a strong influence on wind patterns and satellite motions. Okay, so I think you are now clear with this Newton's first law. Second law. What is the second law? The force acting on any object is directly proportional to the force is acting on any object equal to rate of change of its momentum. What is meant by momentum? Momentum is nothing but mass in product of mass and then velocity. The momentum is nothing but product of mass and then velocity. Mass kg, velocity meter per second inverse. So it is the same with momentum. So when the force is acting on any object, this rate of change of directly proportional to is momentum. Rate of change of its momentum. Okay. So when you have derivatives, you have to introduce new constant d into mv by dt. So m is a constant for the mass of the object, dv by dt. Rate of change of velocity is nothing but your acceleration. So force equal to ma. Force equal to ma. Okay, force is directly proportional to rate of change of its momentum. Okay, so Aristotle is a Newton operates on sliding objects. Okay, 1 Newton. What is meant by 1 Newton? When 1 kg of object accelerated with 1 meter per second square, then it is called 1 Newton. Then it is called 1 Newton. Okay. So, simple words, whenever the momentum of an object body changes, there must be a force acting on it. There must be a force acting on that. This implies that there is a change in velocity, that there must be a force acting on the body. The force and the acceleration are always in the same direction. Newton's second law was a paradigm shift from the Aristotle idea of motion. According to the Newton, the force need not to cause the motion, but only the change in the motion. So Newton's second law is valid only in the inertial frame. Note it down. So this doesn't fully maybe a fully theoretical. Okay, we have to read one by one. Inertial frame. See, in non-inertial frames, Newton's second law cannot be used in this form. It requires some modifications. Okay, 1 Newton is a 2-mark question. 1 Newton is defined as a force which is act 1 kg of mass to give the acceleration of 1 meter per second square. It is called 1 Newton. Aristotle versus Newton approach on sliding object. What will happen? The frictional force will be taken place here. See, in normal cases where the friction is not negligible and the object reaches the bottom of inclined plane, it travels some distance and stop. Note that is the stop because of there is some frictional force acting in the direction opposite to the velocity. When you are holding some objects, it will goes on and stops somewhere. Okay, so the frictional force acting in the direction of opposite. As soon as the body reaches the bottom of the plane, it travels only the small distance and stop because there is no force acting on the object. Essentially, he did not consider the frictional force acting on the object. Okay, Aristotle gives the external force need to be applied to move an object with constant velocity. So Galileo and Newton, they said there is some frictional forces, the net force will be equal to 0. Newton's third law. What is meant by Newton's third law is nothing but for every action there is equal and opposite reaction. For every action there is equal and opposite reactions. Okay. Suppose when the force is acting F1, 2, acting here on the ground, the equal amount of forces, the force on 1 by 2 will be equal to the force on 2 by 1, but in the opposite direction. But in the opposite directions. Okay. So Newton's third law assumes that the force occurs in equal and opposite passes. So it occurs only in the pass of forces. Okay. Isolated forces or single force cannot exist in nature. The Newton's third law tells us that every action there is an equal and opposite reaction. Here the action and reactions of pulse of force, they do not act on the same body but two different bodies. Any one of the forces can be called as the action force, the other forces is called reaction force. The Newton's third law is valid in both inertial and non-inertial frames. Inertial and non-inertial frames. Rotational frames are non-inertial frames. Remember that. Okay, so reading the spring balance discussion on Newton's law. Newton's laws, vector laws, the equation F equal to ma is the vector equation and essentially it is equivalent to the scalar equations. The Cartesian coordinates of these equations can be written as, so F equal to ma, right? So Fi vector plus Fj vector plus Fk vector will be equal to Mai vector plus Maj vector plus Mak vector. Okay, this is how we can write these equations. Fx equal to max, the acceleration along the x direction depends on only one component on force. Okay, if the force is acting only one coordinate, that means only one coordinate on the x axis, then it is called Fx will be equal to max. If the force is acting on the two objects, two coordinate system, Fy along the direction of the Fy, then equal to May. This is only acting in the z direction, then F is equal to Maz. Okay. See, the acceleration experienced by the body at the time t depends on the force which is acting on the body instant time. It does not depend on the force which is acting on the body before the time. It can be expressed as f of t equal to m of a t. In general, direction of the force may be different from the direction of the motion. Though some cases, object may move in the same direction, but as the direction of the force is not always true. For example, force and the motion at the same time. Direction. When the apple falls towards the earth, the direction of the force and the direction of the motion both are in the same direction. Okay. The apple falls towards the earth, the direction of the motion, and the apple and the force are in the downward directions. Force and motion are not in that same direction. The moon experiences the force towards the earth but actually moves in the elliptical orbit. In this case, direction of the force is different from the direction of the motion. Force and motion in the opposite direction. Force and okay, when you are throwing some apple towards above the earth, when you are throwing, you are giving the force against the gravity. The force you are giving against the gravity. So the force is acting, force and the motion of the object will be in the opposite direction. Will be in the opposite direction. Then zero net force, but there is a motion. Zero net force, but there is a motion. The raindrops, okay, raindrops. When the raindrops get the discharged to cloud, it experiences both downward gravitational force and upward air drag force. Upward air drag force. Okay, when the raindrops is falling down from that clouds, the gravitational forces acting in this direction, upward air drag forces are acting in this direction. So both the forces are will be equal to zero. That means net force will be equal to zero, but there is a motion which is in the downward directions. As it descends towards the earth, the upward air drag force increases, and after certain time, upward air drag forces cancel the downward gravity. From none, the raindrops moves with a constant velocity until it touches the surface of the earth. Hence, raindrops comes with a zero net force, therefore there is zero acceleration but non-zero terminal velocity. So the total net forces will be equal to F1 algebraic sum of the other forces. The fifth point, Newton's second law also can be written in the following: A equal to, in the displacement, F equal to ma. The acceleration can be written in the terms of displacement, d square r by dt square, d square r by dt square in the second derivatives. Okay. The sixth one, if no forces acts on the body, then the Newton's second law. Newton's second law. There is no forces acting on the body. Newton's second law will be equal to zero. Ma equal to zero. It implies mass into rate of change of velocity will be equal to zero. So the rate of change of velocity here, there is no change in velocity. The velocity will be equal to constant. Then only the force will be equal to zero. It consists of the first law. However, they should not be taught the reduction of the second law. First law is the no forces acting on the object. Newton's first law and second laws are independent laws. Newton's first law and second laws are independent laws. Newton's second law is cause and effect relations. Force is the cause and acceleration is the effect. Force is the cause and acceleration will be a effect. So it may be second law of riding. We can write the ma equal to f, rate of change of is momentum equal to the force. For example, free body diagram. We must know this one. When the you have kept the book on the table. When you have kept the book on the table, what are the forces will be acting on that book? We are keeping the book on the table or some object in the table. What are the forces will be acting on this object? See, the downward gravitational force, the upward normal force, the upward normal force. So we are taking the downward gravitational forces which is acting downward direction, positive J, taking upward updates of gravity, we are taking the negative. Okay, here positive I vector, here the negative I vector. Okay, next one thing, when an object and the motion. Okay, see, if the objects, two objects, 1, 3.2, according to the Newton law, there are two reaction forces exerted by the book. The book exerts on equal and opposite forces, which is act upward. The book exerts a force which is equal and opposite to the normal force, which is acting downward. Two objects of masses 2.5 kg, 100 kg experience the same force of 5 Newton. What is the acceleration experienced by each of them? So nothing. A equal to F by m. That's it. Okay. So find out. Okay guys, inshallah this is enough for you now. Maybe on next class we'll deal with the forces which is acting on suddenly, that means called what is that? Instantaneous forces. Also it is called something I forgot now. Okay, I hope you just come and collect all your classwork and then test note. Before you are submitting, taking your physics classwork, please tell me that what are the marks you have scored. Okay. Thank you guys. Allah Hafiz.